Hi, this is question 1 for the final project. And question 1 asks us to do text classification using the CNN model. So here it is. We're reading in our train.tsv file. Then we assign our x and y variables. X is the phrases and y is the sentiment for the movie review. Then we do tokenization, where we break down each of the word in the phrases and add them. We do encoding on our y, the sentiment, to categorize the movie reviews. Then we do our training and testing, a 70-30 split. Then we add our layers. Our model is sequential. And for part A, we were also asked to add an embedding layer to see if that makes any difference. And I did. I did it without the embedding layer first, and our accuracy was about 50%. And with our embedding layer, it jumps up to 63%. So it does make a difference. Here's our model fit. And we do our accuracy score. That's what this is. And part B asks to make a plot of the loss model, which we do over here. And I have the image saved here. This is what it looks like. And as you can see, the loss actually increases, which implies that there's an overfitting model. And that's also in part B. We are asked that. So yes, there's an overfitting problem. And in part C, we are asked how we fix this, if there's any techniques for it. And the way we do that is lowering the learning rate, because overfitting usually implies that the learning rate is too high and needs to be reduced. And that's it. Thank you.
My task is about the second one, implementing the text classification on the continuous group data set using the LSTM model, where I have to include the embedded layer, and where I have to include the embedded layer in the design of the model, and I have to report and I have to report whether this leads to a better performance or not. Also, I have to plot the loss and model, and I have to report that. So yeah, let's see the code. So basically, this is the code. This is all the where we are inputting the libraries here. So here we are getting the data from fetch20 news group dataset, and then we are taking it as a train dataset here. So here you can see all the values here, categories here. So and after that here we are taking them into the train data and test data. So actually if I use all the code, if I use the full data set, then the resources have been getting exhausted. I even tried for the third one, using three categories and five categories, but it has been not working. Like the resources have been getting exhausted, so I've been using only the two categories. So that I've stored it in the K here. Sorry, yeah, here you can see ALT, atheism, and autos, Aurica auto. So I've used that one. So I'm only using the two categories to for this data set. And here we have done the vectorization here, using the minimum value of 0.01 and the maximum value of 0.95. And then here we are using the toDens function or method, because the data the matrix here we're fitting with the space matrix, the sparse matrix. So it's being a huge, and it's with the vocabulary as the vocabulary with this data set is huge, and the sparse data matrix is getting increased. So what I've done was I have converted that sparse data matrix into the dense matrix, so that we can reduce its shape. So we are getting is at 1074,2380 for train data and test data and target, and here target here you can see the train target is 1074, whereas the test target is 715 rows. So and so I was using the shape of 0, that is 1074, the number of rows here, and then I've used the LSTM model here, you can see that, and I've been we calculated the score and accuracy. I've run the two epochs here. Text score is 6.80 and test score is 0.55. So also I have plot the graph here. You can see the between of model accuracy and model loss here. Train the test data, and here you can see between the epoch and loss and the epoch and accuracy. So now without the embedded layer, we will be checking the performance here. So the same data here, with the same data set here, we are finding the max review length. We are doing the tokenizer, and then we are splitting the data here, x2 and y2 and x test and y test, and then we are building the model here, and then we are fitting the data here. We are with help of the history object, we are finding the we are plotting the data, and you can see loss and accuracy. So after I have run the Firefox, so here you can see the model accuracy and model loss. So the model accuracy was 0.91, so without the embedding layer, but when I added the embedded layer, the accuracy is 0.55. So definitely adding an embedded layer is decreasing the accuracy. So this was the insight that we are getting from this task. Yeah, thank you.
For question 3, we have two different data sets. So here we have used the 10 monkey species data set, and here we have done the image classification using the CNN model. And the first part is we need to report the classification result with and without doing the scaling, how the performance varies, and we need to save the model and predicting one of the test data from it, and checking whether it is predicted correctly or not. So here is the code for it. I have run in the Google Colab. So with first thing I have done with scaling and also predicting one of the image. So first we'll import all the necessary libraries, and here we are reading the data from the data set, and printing the labels, and we need to give the path for the training and the test part. Training generator and test generator are defined, and here for this image underscore show, this function is defined only to print the images from the specific path, just to verify. And here it is reading the images from the folder. And next, normalizing the data. Here I have applied the scaling for the training and the testing part, and one hot encode is applied, and then we are creating the model, compiling it and fitting the model. And additionally I have used the history object to print the loss and accuracy for it, and here it will plot the graph, and this is being saved as model q3.h5, and the same model is being loaded here. We can see this here. It's taking time. And next, here the prediction is done on the model. Here I have defined these with the help of the output. Here this is being given in the text data of monkey labels. This is the common names of it. So from this, one of the test image, a random image will be printed, and that image label will be displayed at the output. So here how it is. So in this, here this is the data. These are the common names of those species, and totally we have found 1098 images belonging to 10 classes, and there is 272 images that are belonging to other 10 classes. So here I have predicted 2 images which belongs to the group. So this is the path, this is the number label of the image, and these are the dimensions of it. And then it is validated with the epoch values, and this is the graph plot for accuracy and for the loss. The same model is loaded here. Here the loss is 6.31 and the accuracy is almost 66%, and here the prediction is done. One image is black-headed night monkey, and the other is Nilgiri langur, and the third is Blad Okari and Patas monkey. So I have predicted the 4 images. This is how it is done with scaling. So without scaling, I have removed the scaling part here. I have removed the scaling. Earlier it was there, and here just plotting the loss and accuracy. So here this is the accuracy and loss graph, and we can see the loss, it is 2.3 and accuracy is 9.5. So without scaling it has been improved. And next, for the question 4, we have a data set New York Times comments and headlines. So in this, we need to create a model and pass a sample headline or a word and predict the text of it. So here is the code for it. So first thing, we will import all the necessary libraries and providing a random seed and providing the directory or the path for the data set. And here we are only considering the articles data set for it, in which only the headline and the keywords are the target X and Y labels we have taken. So from this, the tokenizer is applied. And next, we are generating the padded sequences and model creation and printing the model summary and fitting the model. And the next part, this is generating the text. So in order to give the input and verifying the output, so a function is defined here. So this is the final output, that giving a keyword, it generates the prediction on it.
Hi everyone, in this video I'm going to explain the fifth question which have been given for the exam 2. So in this question there are two parts. Like the first part is I need to take CIFAR10 dataset, and first I need to pass it through an autoencoder, and then the output of this autoencoder should be passed to either CNN or LSTM or 3 layers model to classify the data. So I have used CNN for this. And coming to the next part, for the same dataset, like for taking the CIFAR10 dataset, apply PCA on the dataset and then pass it to the same technique which we have used in the previously, that is CNN. I'm using CNN, so I have taken the second part also as in CNN. So I need to pass that in CNN, and then I need to check the result of both the approaches. So coming to the first part of the question, so here is that. So I have included all the libraries which are required. So I have so the input which we have got is of picture data. So its resolution is 3,32,32. So I have converted multiplied that, so I will be getting 3072. So with this I have kept only one layer, one encoding layer and one decoding layer. And then I have used optimizer as ADA delta, and after I have created the autoencoder model, and then I have downloaded my CIFAR data set from internet using this. And then my data set will be having each image will be having configurations from 0 to 255. So for that I have normalized all those fields from 0 to 255 to 0 to 1, and by using these functions. And next this all these data sets will be of 3 dimensions, like 3, 32, 32. So I have changed them into 2D, like the length of the field, comma, and all those 3 fields will be fitted into the single. So that is 3072 if you multiply that. So I have just printed the shape of xtrain and test data, and then I am fitting the data into autoencoder. I have used history, and even I have used only 10 approaches so that it will be faster. So after fitting this model into my autoencoder, and then I have plotted the graph for this, regarding accuracy and variable accuracy and loss and variable loss. So this is the graph for that. And after that, all the fields. So next what I have done is I have taken all the trained data into train 1, and I have applied the prediction of autoencoder on this, so that the new image will be predicted image. Like after autoencoding, what's the image will be, that will be stored in xtrain 1, and that in what are the images which are there in xtest after passing through autoencoder, that will be passed into xtest 1. So this xtrain 1 and xtest 1 are in the shape of 5000, 50,000, 3072 and 1000, 3072. So I have reshaped them again into the normal content, like 32, 32, 3, and 5000 will be the count total number of xtrain arrays. So then I have prepared a CNN model this is everything is random, like I have taken 0.332. This will be the input shape. This should be correct. And then I have used some dropout layers and max pooling today, and then flattened and dropout something. And in the last while passing through CNN, I have used 20 epoches. So after that I have passed my data sets like Xtrain and Xtest into my fitted into my model with epoches as 20. So after this I got an accuracy of 28.17. so for the same data set, like I have taken the same data set, CIFAR10 data set, and just like the previous one, we have normalized it into 2D, like previously it was 4D, so now we have reshaped into 2D, and then I have passed this data, passed this Xtrain and Xtest to PCA, and Xtest to PCA, and this new whatever the fields Xtrain and Xtrain will become Xtrain PCA once I send from PCA, but PCA will be having but Xtest underscore PCA and Xtrain underscore PCA will be having dimensions of 2D like 50,000, 3. So I have again converting them into original shapes like 50,000, 32, 32, and then I'm passing it to the same CNN model with the same epoches I have used previously. Also I have used 20 epoches, and here also same epoches. I haven't changed any lag rate or decay rate. So I have compiled it and I have fitted into this model. So I have used history2 as the object here. So I can find like the accuracy is 47.85, and the previous step it was like 28.17. So by looking at this, we can say that the PCA and then the CNN is better than autoencoder and the PCA.